Hi, my name's Brett Allison, and I'm a senior performance consultant with IntelliMagic. I wanted to talk to you today about assessing your environment to determine which candidates are good for Flash. Over the last few years, we've heard about how Flash technology is going to completely disrupt the data center. Has it disrupted your data center? Have you added Flash technology to the data center? Most likely you have, and most likely you've added a significant amount of Flash in your environment. Maybe you're getting ready to add Flash and you want to see how much of your capacity is good candidates for Flash. This is an important question to answer because even though Flash is less expensive than it used to be and almost on par with spinning disks, it's still more expensive than nearline drives. Let's take a look at workload categorization for different technology types. For SSD and Flash, the cost per terabyte is high, so you want to reserve this for workloads with high access densities, predominantly read cache unfriendly workloads, with transfer sizes less than or equal to 64 kbytes. The reason for focusing on read-miss workloads is that the Flash or SSD technology is able to deliver the random read requests at a very high speed. In fact, the random reads are as quick as sequential reads, as there is no seek time with SSD Flash. This makes the SSD Flash an excellent place to store highly accessed read-miss data that just won't fit in the server or storage cache. The reason for relatively small transfer size is that there's really not much benefit in placing large sequential block transfer workloads on Flash. They perform just as well on spinning drives, such that most of the auto-tiering technologies tend to place them on enterprise tier drives instead of using the Flash or SSD to store them. For enterprise drives in a mixed environment, they should be the target for both reads and writes. Random and sequential workloads with block sizes greater than or equal to 64K are fine. This is because the spinning or enterprise drives are optimized to handle sequential streams efficiently at a cost that is generally lower than enterprise Flash. For nearline drives, the primary concern is that the target workloads should have a low access density, less than 100 per drive, for example. Other than that, the block or size of the workload doesn't really matter. Now let's take a look at the SSD candidate report and see how it might be used. So we talked a little bit about which workloads should be on Flash. And what I have before you is a Flash candidate report. And what I've done here is I've grabbed all of the volumes in the environment. You can see the device number and the volume label, which storage pool they belong to, their labels, and the SVC names or the DSS names in this case, which pool they're a part of, the read-miss IO rate. So we'll go ahead and I'm going to get rid of that one. And I'm going to say best fit, all columns, so that you can see the read-miss IO rate. So I see that the read-miss IO rate, I've sorted it by that number. So this is the volume that has the highest read-miss IO rate. I've also put in the front-end transfer size. I'm really looking for things that are 32K or less, but I could go as high as 64K. And then what is important to have when you're trying to size how much capacity you need is looking at the utilized capacity. Now you may have conditions where certain things are already flashed, like maybe this is already flashed. So I could filter that out. I could say is not like flash, right? And when I do that, then I should be able to get rid of all of these flash. And let's see, custom is not like star flash star. That gets rid of all my flash, so that way I'm at least not pulling up things that I know are going to be already on flash. So I'm looking at maybe just the things that might not be on flash but might be good candidates. So then I'm going to export this to CSV. Really what I'm trying to get a sense for is which volumes would be good candidates. I will filter out does not equal star flash star, and I will accumulate this utilized column. Let's go down here. So I'm looking in this environment, and I want to know how much capacity I'm talking about here. And it turns out in this environment, I've got 407,980 gigabytes of potential capacity that would be good candidates for flash based only on the transfer size. Now, if I start looking at it and I say, well, they're not doing any read offs, and this is my read miss rate, I might want to say, man, I've only got, a few dozen hosts that are actually part of that. So that really reduces it down. So if I then look at maybe going down to like, we'll just say 20 ops or greater, I'll go ahead and insert a line here, and I'll say I just really want to know the cumulative for the ones that have at least 20 ops or more. And it's 157. That's a big difference. So between 400 and 157. So you really want to look at the workload rate as well as the capacity for those. And it's really going to turn out that most of the capacity, I'd probably be more interested in these that are doing like 100 read misses per second versus things that are lower than that. Most of those that's going to be a lot less capacity. So if I do that, looking at just ones that are around 100, that gets me down to 38 gigabytes of space. So for this workload, the potential flash capacity is really only around 38 gigabytes. Hope that was helpful. If you have any questions, feel free to send me an email, brett.allison@intellimagic.com. Thanks.